Welcome to Ask and Learn.
We are given the solubility reaction and its value for the change in Gibbs free energy at standard conditions at a temperature of 37 degrees Celsius, which when converted into Kelvin comes out to 310. From this information, at these conditions, we want to determine the concentration of Ba2 plus ions in solution. And from the information in the problem, we can conclude that the concentration of Ba2 plus is equal to the concentration of SO4 2 minus in solution. So we can begin by writing out the equilibrium constant expression where K equals, when we look at the aqueous species participating in this reaction, it equals Ba2 plus, that concentration value, multiplied by concentration of SO4 2 minus. But based on this relationship, we can say that this equals the concentration of Ba2 plus squared. And we also know an equation to relate the equilibrium constant with the change in Gibbs free energy value. So once we solve for that value for K, we can take the square root of it to isolate and find the concentration of barium ions in solution. So the equation that relates K and delta G is K equals E to the power of negative delta G over RT. So K equals E to the power of negative delta G, which we are given as 59.1 kilojoules per mole. But we should convert that into joules per mole so that we can cancel off the units of the constant R. So we should multiply that by 1,000 to get it from kilojoules to joules per mole. And then we divide that by the constant R, 8.314 joules per mole times Kelvin, times that temperature of 310 Kelvin. And now, when we cancel off the units of Kelvin and joules per mole, we can successfully take e to the power of this quantity since it is dimensionless, and we come up with a dimensionless value for K to be equal to the concentration of Ba2 plus squared, so that when we take the square root of this K that we found from this equation, we can get the concentration of barium ions to be equal to 1.05 times 10 to the power of negative 5 moles per liter.